Hi everyone, so we're going to be looking at elements, compounds and mixtures in this video. So let's say pure substances. A pure substance will consist of only one type of thing in it. And that type of thing, that material could be an element or it could be a compound. But you will not find two different things or three different things in a pure substance. And also, pure substances have fixed properties, whether it is chemical properties or physical properties. And a pure substance, you would not be able to perform any type of separation with it. If you have a pure substance which is made up of an element, if you heat, this little triangle means heat, if you heat an element, because an element is a simpler substance, it cannot be broken down into any simpler substances. This is what an element is. It cannot be broken down into any simpler substance. If you heat an element, the only thing that you can get is a compound. And when you're heating an element, if you're getting a compound, means you're going to add something to it. So if you heat an element, you will observe an increase in mass. And why do we observe an increase in mass? I'm going to refer back to the law of conservation of mass. Because when you're heating here, this means that you are reacting with oxygen. This is what heating means, reacting with oxygen. So if you look here, I have an element. So this is a pure substance, so you can see only one type of particle. If I heat an element, I'm reacting with oxygen. So the red ones are oxygen. So this is an oxygen molecule. So a molecule, this is also an element, right? And when I react these two, I'm going to get a compound. So in that case, blue and red together. And if I'm getting a compound, because of the law of conservation of mass, you must observe an increase in mass, right? But if you take the same process with a compound, there's two possibilities. You heat, you get another compound, or you heat and the compound decomposes and releases gas. Use little diagrams here. So I have a compound, so you can see there's two types of particles here, and throughout the compound you will see only these two types of particles. So it's still pure, so it's not combined with anything else. So it's only blue and green together. So if I heat this, so let's say oxygen is still red, right? So here I have a compound, blue, green and red together. So I will observe an increase in mass. Now if this compound will decompose and release a gas, so it's giving me only blue, and the green and the red is forming a gas that escapes. This means that I will observe a decrease in mass. Now let's look at elements in more details. So elements will consist of only atoms with same number of protons. You can have atoms with different number of neutrons. And that's okay, and it will still be the same element. And if you still recall your Form 4 and 5, you will remember that these are called isotopes. Elements with same number of protons but different number of neutrons. So these are still elements. And these are a few examples. So bromine exists as Br2. That's why you will see these two combined. So these are diatomic. So you have two atoms of the element that combine. So you have diatomic, I will use the term molecules here, diatomic molecules. So they are combined, but you only have one type of substance. So it is element and it is pure. Helium is monoatomic. It exists as He. It does not combine. And then you have aluminium. This is also an element. And this one you can see the metal lattice. And if you still remember the term lattice, lattice means regular 3D arrangement, and it could be arrangement of any type of particles, could be atoms, ions, or molecules. So in this case, because it is a metal lattice, you will remember that these are cations in a sea of mobile electrons. So this is still elements. Now, elements can exist as atoms or molecules, like I mentioned. So this is diatomic molecules. It's still an element. And this is the definition of molecules. Molecules are groups of two or more atoms that are chemically bonded by covalent bonds. So this is what molecules mean. Now let's see examples of elements, the way that they exist together. So neon, this is monoatomic, along with helium. These both of them are monoatomic. Hydrogen, oxygen, these are diatomic, so they exist as HH. Here, that little bond here, this is a single covalent bond. So this is how the molecule looks like. So HH, this is diatomic. Oxygen molecule, in the oxygen molecule, you have double bonds. So this is a double covalent bond. And this looks like this. So you have oxygen and oxygen. This is again diatomic. Nitrogen molecule, you have triple covalent bonds. And looks like this. And this is also diatomic. So all of these are diatomic. You should be familiar with that. So hydrogen is H2, oxygen is O2, nitrogen is N2. Now the sulfur molecule is special. Sulfur has a crown structure and it exists as S8. And if I would have to draw the structure of sulfur, it would look like this. It is a crown structure. Phosphorus is also special. Phosphorus exists as P4, which is called white phosphorus. You have white phosphorus and red phosphorus. And white phosphorus looks like this. So 1, 2, 3, 4, and then they are all bonded to each other. Like this. So this is white phosphorus. Red phosphorus exists in a polymeric form where there's a lattice in it. So we're not going to look into that. So these are different forms of elements, and in all of them you will see that there is only one type of substance. And even if you break it down, you will still get, for example, if you break sulfur, if you break this crown structure, you will still get sulfur. If you break this down, you will still get phosphorus. So you're not breaking it down into any simpler substance. Compounds now, they will consist of atoms of different elements chemically combined together in a fixed ratio. This is very important, which means that whenever you see the compound water, which is H2O, there's always going to be 2 hydrogen with 1 oxygen. There's always going to be that ratio. So this is what it means by a fixed ratio. In mixtures, on the other hand, there is no fixed ratio. If you are going to make a mixture of hydrogen and oxygen together, you won't have any, you can have as much hydrogen as you want and as much oxygen as you want, ensuring that they are not reacting with each other. But if they react with each other and you're getting water, then it's always going to be 2 hydrogen combining with 1 oxygen. Same thing for aluminium oxide. So it's 2 aluminium combining with 3 oxygen. Glucose, this is C6H12O6. So there's 6 carbon to 12 hydrogen to 6 oxygen. Always the case. And compounds will have different properties than its constituting elements. So water is very different from hydrogen or from oxygen. So the properties of water is different from the properties of hydrogen and oxygen that make it up. You have another example. Sodium is reactive, melts at 98. Chlorine is poisonous, whereas sodium chloride is salt, so it's not poisonous, dissolves in water and has a very high melting point. So you can see how the compound is different from the constituting elements. Mixtures now, these will contain more than one element or more than one compound without any fixed ratio, not chemically bonded. So you can see there's 1, 2, 3, 4 conditions for it to satisfy the mixture. More than one element or element and compound or more than one compound, no fixed ratio, not chemically bonded, and they can be separated by physical methods. And the physical methods, we're going to see that in more detail. So you have filtration, crystallization, distillation, chromatography. These are the physical methods. And mixtures have variable properties depending on their composition. For example, air will consist of the different gases. So you can see that these different components of air, yes, we know that oxygen, for example, we have 21% of oxygen, 78% of nitrogen. Yes, we know the composition, but it can always vary. And water vapor, you know that there is a variable amount of water vapor, and depending on the quality of air, the amount of carbon dioxide will be different. So air is a mixture, and even if we know the composition, it's not a fixed ratio, it's just a percentage composition. Blood contains all these things, and amount of all of them can vary. So you will see this diagram that I gave you in the first lesson. Try to do this exercise again and see if you still have the same issues. So what I'm looking for is find which one of these are pure elements, pure compound, mixture of elements, mixture of compound, mixture of elements and compounds. Pause the video, do the exercise, and then you check your answer. Check your answers. You will find a recap of element, compound, and mixtures. And you will find another form of recap, which is a map. Use this and you do the questions that have been provided in the next activity.